Hello everyone, my name is Carly Lancaster and I'm a scientist at TACO, where we perform high-dimensional cytometry analysis for clinical trials and diagnostic development. I'm at the AACR I/O conference in Los Angeles, California, where I will be presenting some of our recent work regarding the stability of live whole blood samples for high-dimensional cytometry analysis. Now, as you may be aware, an estimated 80% of samples intended for cytometry analysis are collected live, meaning that these blood samples have been taken from the patient and have not undergone any sort of preservation or fixation of any kind. And despite the recent advances in fixation as well as epitope detection, it is still considered the gold standard to use samples that have been aged for 24, 48, or even 72 hours post-blood collection. And so at TACO, we are really dedicated to providing our customers with quality and reliable data, and that quality reliable data relies in part on the quality of the specimen, which has prompted us to interrogate the question, is fresh really that fresh? Meaning, are blood samples that have been drawn from the patients at clinical sites and then shipped or left out for extended periods of time really the same as the sample at time zero? And can fixation of whole blood samples after draw actually prevent cell loss as well as loss of any cell types that may be less stable, in order to provide our customers with high quality data that is reliable and helps inform them about their clinical trial? We tested this question using two different types of cytometry analysis. One is known as mass cytometry and the other one is spectral flow cytometry. And we used 3 healthy donors to help us interrogate this question. So I'll turn your attention here, and this is some of our mass cytometry data, in which we again drew blood from 3 healthy donors, and then using our 41 marker panel, we were able to stain these samples with a variety of different antibodies that are tagged with heavy metals, and then ran these samples on mass cytometry. And these are samples that we let sit out for 5 hours, 7 hours, 9 hours, 27 hours, or even 51 hours post-blood draw. And what I hope you can appreciate, this is just a bar chart of the median percent change of all analyzed cell populations, where we have the analyzed cell populations here on the y-axis and the median percent change from the baseline, which is our time 5 hours time point. And what I hope you can appreciate is that over time we see a large change in the frequencies of these cells within the population. Specifically, we see large changes in our monocytes, and including these monocyte subsets such as classical monocytes, intermediate monocytes, and non-classical monocytes, or even these MOMDCs. Moreover, we see major changes in these non-cytolytic NK cells, which are our NK cells that are CD16 and CD56 positive, as well as substantial changes in rare lymphocyte subsets, such as these CD4 TEMRAs and double positive T and double negative T cells. Really what we want you to appreciate from this graph is that over time, we see major changes in the population frequencies of these cells, indicating that there is a large difference between your sample at time 0 and your sample at time 51, indicating that maybe fresh isn't really all that fresh. So, of course, that's just one type of cytometry analysis that we could use to ask this question. So we took it a step further and we performed a very similar experiment, but using spectral flow cytometry. And again, we used 3 healthy donors, and we aged the samples for 0, 24, 48, and 72 hours, which, if you remember from earlier, is what I said was the gold standard for use of live cell processing. I should also mention that we compared these data to samples that we fixed using our in-house Toku kit, which uses a stable lyse, stable store method in order to effectively lyse red blood cells and store your blood sample collected at the clinical site that can be either stored in a -80 freezer or shipped directly to us on dry ice. So one of the first things we noticed with the live samples in comparison to the fresh samples is that the neutrophils actually lost CD66B positivity over time. So we'll turn your attention here to this dot plot where we have our events plotted against CD16 and CD66B, which allows us to effectively gate neutrophils. And as you can see at time 0, this gate here is able to very easily be drawn around the neutrophil population to effectively gate out these neutrophils and prevent them from bleeding into our non-granulocyte gate. However, as these samples sit out over time, this CD66B population actually starts to lose its CD66B positivity and bleed into this CD16 high, CD66B low population, which further causes these neutrophils to bleed into that non-gran population, which can distort our downstream interpretations of the data. And this trend continued on to time 48 and time 72, where we see, again, loss of CD66B positivity from these neutrophils and bleeding into this non-gran population here. And again, very seriously exacerbated at time 72. And if you actually want to look at the percentages, we see that of all of the events that were plotted against CD16 and CD66B, we see that in this neutrophil population, these neutrophils made up about 93.89% of that population. However, as time goes on, when samples have been sat out for up to 72 hours, you actually end up with only 39% of those same events within that population. Once again, indicating that your fresh sample is really not that fresh. But I haven't really made an argument for fixation. Why should you fix? Why is it important? And what does that mean for you? Again, we took this data comparing our live samples from 3 donors over 3 time points, 24, 48, and 72 hours, to our baseline at 0, and compared those to fixed samples. And what you can see here, and what I hope you can appreciate, is that unlike live samples, which we see a significant loss in the cell count over time, you actually have about a 49% loss of your total cells that you started with at time 0 compared to time 72. Compared to these live samples, our fresh samples actually show a relatively stable cell count over time, indicating that if you fix your cells upon collection, that you're not going to be losing massive amount of cells as your samples get shipped to the cytometry site or to the processing site. Moreover, if we take these samples at each of these time points and we perform spectral flow cytometry analysis, we see that there are changes in population frequencies over time, indicating that cell loss is not necessarily uniform over time. So we see here that once samples have been aged for 24, 48, or 72 hours, we see significant reductions in our neutrophil populations, as we discussed earlier. We also see an even more dramatic loss of our monocyte populations. We see here that we go from having a monocyte population that's about 20% of all non-gran cells that decreases to 5% and even less than 2% by day 72. This indicates that processing your samples live can actually impact your conclusions about your data. And what I would like to point out is that fixation actually preserves these population frequencies over time. So not only is it preserving your cell count, but it's preserving these population frequencies over time. Once again, indicating that maybe fresh isn't really all that fresh. And then if you wanted to see a visual example of this loss in monocyte levels over time, you see here, this is time 0, time 24 hours, 48, and 72 hours. And the samples on top are the dot plots of our live samples, and on the bottom is the dot plot of our fixed samples. And what I hope you can appreciate right off the bat is there are just less events altogether. Not only do we see loss of the number of events over time in this live samples, but this is not something that we see in our fixed samples, where we see relatively stable event counts over time. Once again, indicating that fixed samples not only can preserve your population frequencies, but fixation can also preserve your cell count over time. And just to illustrate this point a little bit further, if you're interested in looking at it in a bar chart format, we see that once again over time, we see distortion of these monocyte and neutrophil populations over time. These monocytes actually fall out of spec at 24 hours, followed by neutrophils at 48 and 72 hours. And that brings us to our conclusion, which is the answer to the question, is fresh really that fresh? The answer is not really. We can conclude that live processing of samples results in nearly half, a loss in nearly half of your cells that you collected at time zero. Not only that, but we see that this cell loss is not uniformly distributed across populations, and that monocytes and neutrophils seem less able to withstand storage at room temperatures or ambient temperatures. To be more specific, we see that monocytes show an 87% reduction when processed after 72 hours, that neutrophils show a 48% reduction when processed live at 72 hours, and that these rare lymphocyte subsets show a greater than 25% change in frequency when processed within 51 hours. And altogether, what I hope that this shows you is not only that fresh isn't really that fresh, but that fixation can actually preserve your cell count and your cell frequencies over time. And with that, I'd like to thank you for your attention, and if you have any questions, please visit us at our website or on our dashboard at app.taco.bio, or shoot us an email, or even give us a call. And with that, thank you very much.